Okay, so here we're going to look at general terms of a quadratic sequence. Okay, so the general term of any quadratic sequence will be of the form t of n is equal to an squared plus bn plus c. Okay, so we know this is what quadratic tends to look like. Okay, where a, b, c are an element of the reals, a is not equal to 0 and the second difference is equal to 2a. Okay, so this will all make sense once we go through a few examples. So here I have an example. Find t of n, the general term of the quadratic sequence 13, 17, 29, 49. Okay, express your answer in the form t of n is equal to an squared plus bn plus c. Okay, right, so the first thing I do is I draw out, okay, this is my sequence 13, 17, 29, 49. Okay, right, I get my first difference. If the first difference is the same, it would be linear. If the second difference is the same, it's quadratic. Okay, and if we're going on to a third difference, okay, if it's doubling, tripling, quadrupling, it's going to have to be an exponential function. Okay, but we know it's going to be a quadratic. They've given us enough information. That's what they want us to find. So the first difference from here to here is 4. 29 take 17 is we're going up 12, and 49 take 29 we're going up 20. Okay, so this is my first difference. Then now I have here, it's my second difference. Okay, so difference between 12 and 4 is 8, and the difference between 20 and 12 is 8. Okay, so my second difference is 8. And up here earlier, we said that the second difference is equal to 2a. So we want to find out what a is equal to. Right, so my second difference is equal to 8. Okay, so find the value of a. So second difference is equal to 2a. So I'm going to go 2a is equal to 8. That means a in this case has to be 4. Right, then I have to use, okay, so use tn is equal to an squared plus bn plus c to form two equations in b and c. Okay, so remembering that n is equal to the term number and a is equal to 4, right? So basically I know my equation is going to look like something like this. Tn is equal to 4n squared plus bn plus c. Okay, right, my first term, okay, so this quadratic sequence, it was 13, 17, 29, 49. Okay, so it's 13, 17, 29, 49. Okay, so we'll just double check that there. I took it down right. So it was 13, 17, 29, 49. This is term 1, term 2, term 3, terms 4. But for this particular question, you're only ever going to need term 1 and term 2. Okay? Alright, so what I do is I have to go, right, so I have term 1 is equal to 13. Okay, so term 1 is equal to 4 bracket, so wherever I have an n I put in 1, okay, because it's my n is my term number. Okay, so it's 4 bracket 1 to be squared plus b times 1 plus c is equal to 13. So I have 4 plus b plus c is equal to 13. b plus c is equal to 13. This is plus 4 over here. When I bring it over, it becomes minus 4. So I have b plus c is equal to 9, and that's my first equation. Right, the second term in my question here, it was term 2 is equal to 17. Okay, so now wherever I have an n, I need to put in 2, and I let it equal to 17. So I have 4 bracket 2 to be squared, plus b bracket 2 plus c is equal to 17. Right, so 2 to be squared gives me 4. 4 by 4 is 16. Plus 2b plus c is equal to 17. So I'm just going to tidy that up now. So what I have then is I have, I just write it out there. Okay, so I have 2b plus c, so that was 16. So 2b plus c is equal to 1, because 17 bring over my plus 16 becomes minus 16. So now I have, okay, so I had my first equation was, okay, my first equation was b plus c is equal to 9. Okay, so I write that down. B plus c is equal to 9. My second equation I'm after forming in b and c is 2b plus c is equal to 1. Right, this is a simultaneous equation. This or this comes back into play, so simultaneous. Okay, so the simultaneous equation, right, your first step for a simultaneous equation you need to remember is you need to eliminate either your x or your y, but in this case it's going to be your b or your c. Okay, I'm going to get rid of my c because all I need to do is I need to change the signs. Okay, because what I need to do is I need to get one of them to 0b or 0c, okay? I just changed the top line up here, so I have minus b minus c is equal to minus 9. You have to change the signs the whole way across, okay? So minus by plus, or minus and plus, they're gone, it's 0c. Then minus b plus 2b will just give me plus b, and that's equal to minus 9 plus 1 is minus 8. Okay, so I figured out that b is equal to minus 8. Now I have b plus c is equal to 9, so I'm just using one of these ones. So I know that b is equal to minus 8, so I sub that in. Plus c is equal to 9, so I have c is equal to 9. Bring over my minus 8, it becomes plus 8, so I have c is equal to 17. So my general equation for this particular pattern is t of n is equal to 4n squared plus 8n plus 17. Okay, because remember we have t of n is equal to an squared minus or plus bn plus c. Okay, so that's my general one there. Now what I have to do is another example. Okay, so here I have the number of computers sold per day for a major retailer over a 5-day period is recorded. In the table below, day 1 is Monday, day 2 is Tuesday, etc. Okay, right, so I have day 1 they sold 10, day 2 they sold 16, day 3 they sold 18, and so on. The first thing it asked me to do was draw a graph to illustrate the information on this table, okay? So I put my days at the bottom and my computers sold here, okay? So for day 1, there was 10 computers, so I plot that point, so it's 110. Day 2, there was 16 computers sold, so I go 2, 16, okay? Day 3, there was 18, so I go 3, 18. Day 4 there was 16 computers sold, so I go 4, 16, and day 5 there was 10 computers sold, so I drew that, plot that there. Okay, so it's going to be 5, 10. Right, then it asks me from your graph what is the busiest day for computer sales, and day 3, okay, Wednesday is the busiest day as it has the highest point in the graph, and you will be even able to tell that from your table. Okay, so this is the 18, this is the most as ever sold in any single day. My next thing I was asked to find my second difference. Okay, right, so I write out my sequence. Okay, so it's 10, 16, 18, 16, 10. Okay, so 10, 16, 18, 16, 10. Right, my first difference here is 6. My next difference between 16 and 18 is plus 2. Between 18 and 16, I'm going down 2, so minus 2. And between 16 and 10, I'm going down 6. Okay, right, the difference between 6 to 2, I'm going down 4. The difference between 2 to minus 2, I'm going down 4 again. And minus 2 to minus 6, I'm going down 2 again, or down 4 again. So my second difference in this particular case is minus 4. Okay, so we know it's quadratic because the second difference is the same. Right, so my second difference is equal to minus 4. Then I'm asked to find a formula that describes the number of computers sold for any given day. Right, so I'm trying to find a general formula. T of n is equal to an squared plus bn plus c. Okay, so my second difference is equal to 2a. So 2a is equal to, we figured out that my second difference is minus 4. So 2a is equal to minus 4. A is equal to minus 2. Right, so basically I'm subbing in here minus 2 for this a. Right, so T of n is equal to an squared plus bn plus c. Right, my first term, T1, was equal to 10, okay? So term 1 is equal to 10. So now wherever I see an n, I put in 1, okay? So I go minus 2, because we know a is minus 2, bracket 1 to be squared, plus b, bracket 1, plus c is equal to 10. So I have minus 2 plus b plus c is equal to 10. So I have b plus c is equal to 12, because when I bring over my minus 2, it becomes plus 2. Then I have term 2 is equal to 16. Okay, right, so I know that a is still minus 2, so it's minus 2. Wherever I see an n, I put in 2. So it's 2 to be squared, plus b, bracket 2, plus c, and it's equal to 16. So 2 to be squared gives me 4. 4 times minus 2 is minus 8. Plus 2b plus c is equal to 16. So now I have 2b plus 6 plus c is equal to 16. This is minus 8. When I bring it over, it becomes plus 8, and that gives me 24. So these are my two equations. I'm going to have to do a simultaneous equation with these. Remember, for a simultaneous equation, you need to eliminate either your b or your c. It's easier in this case to eliminate your c, because all you need to do is change your signs of your c, and you get it rid to 0c. So when I change my signs, I change it at the top. Okay, so I have minus b minus c minus 12. So minus b plus 2b gives me b. Minus 12 plus 24 gives me plus 12. So I have b is equal to 12. So now I go sub it back into any one of the lines. Doesn't matter which one you choose. So I have b plus c is equal to 12. So I have 12 plus c is equal to 12. So basically c is equal to 0, because if I bring this over, it becomes minus 12. So then my general form, t of n, is equal to minus 2n squared plus 12n. There's no plus c to add on, okay? Then I have here the next part of this question. It says, the manager expects the sales of the computers to continue to follow the same patterns over the weekend. Use your graph to explain if she should consider opening the shop on a Saturday. Right, I said no, she should not open at the weekend, as the sales reaches their max on day 3 and have decreased since. Okay, so we can see that it's literally going to keep decreasing if she keeps her shop opened. Okay, and we know that day 6 is Saturday. Then it says, check your answer in part D using the formula derived in part C. Okay, right, so this is my formula derived in part C. Okay, so t of n is equal to minus 2n squared plus 12n. We know that day 6 is equal to Saturday, so that's going to be filled in for n. Okay, so t6 is equal to minus 2 bracket 6 to be squared plus 12 bracket 6. So then minus 72, when I put that into my calculator, plus 72 is equal to 0. This basically tells me if she opens on Saturday, she's going to sell no computers. So it's not worth her while opening on Saturday. Okay, so she shouldn't open, which confirms what we just said in part D. Here I have another example, okay? Alright, so here's my sequence, okay? So 3, 10, 21, 36. So I'm trying to find the nth term of the sequence, okay? So the nth term is another way of saying the general term, okay? So the first thing I need to do is I need to check, is it linear or is it quadratic? Okay, so it tends to be quadratic when they want me to solve this, okay? So the first thing I have is I write out 3, 10, 21, 36. My first difference between 10 and 3 is plus 7. Between 21 take away 10 is plus 11. 36 take away 21 is plus 15. Right? Then I have to get my second difference. Okay, so 11 take away 7 is 4. 15 take away 11 is 4. Okay, so my second difference is 4. And remember, we said that my second difference is equal to 2a. So 2a is equal to 4. A is equal to 2. Okay, so I have t of n is equal to, this is my general formula, we just need to find out what's my b word and what's my c word. Okay, so it's an squared plus bn plus c. Right, so now I know that a is definitely going to be 2, so it's t of n is equal to 2n squared plus bn plus c, and we need to figure out what is b and what is c word. Okay, so the first thing I do is I go term 1 is equal to 3. Okay, so term 1 is equal to 3, term 2 is going to be equal to 10. Okay, so wherever I have an n, I put in 1. Okay, so it's 2 bracket 1 to be squared plus b bracket 1 plus c, and that's equal to 3. Okay, so 1 to be squared is just 1, so 2 plus b plus c is equal to 3. So I have b plus c is equal to 1, because 3, bring over this plus 2 becomes minus 2, and that just gives me 1. Last part here then is term 2 is equal to 10, so 2n squared plus bn plus c. So wherever I see an n, I put in 2, so I go 2 bracket 2 to be squared plus b bracket 2 plus c, and that's equal to 10. So I go 2 to be squared is 4, 4 times 2 is 8, so 8 plus 2b plus c is equal to 10, 2b plus c is equal to 10, take away the 8, that gives me 2. So now I have my two equations made in b and c that will help me form my simultaneous equation. The first one was b plus c is equal to 1, and the second one is 2b plus c is equal to 2. Right, I just changed the sign of the top line to eliminate my c, because I need to eliminate one or the other. Okay, right, so minus, minus, minus. I changed signs the whole way across. So I get 2 minus b plus 2b is just b, minus 1 plus 2 is 1, so b is equal to 1. Then I sub in, okay? So I sub into either my top or my bottom line. So I have b plus c is equal to 1. And then I have 1 plus c is equal to 1. C is equal to 0. So then my general term is just 2n squared plus 1n. And that's it, fully completed.